In this video, I've taken 8 questions, including not 8, I think 12 questions, including 4 MCQ and other questions from definite as well as definite integrals. So let's begin with the first question. Now, in this question, it is given that if 0 to a integration f 2a minus x is equal to m and integrals fx 0 to a is equal to n, then we have to get the value of this. Now, if you remember that we have a direct property based on this, and the property is this, right? So in order to get integral 0 to a fx dx can be written as 0 to a fx dx plus 0 to a f2a minus x. So we can directly apply this property, that is 0 to 2a fx can be written as what? 0 to a fx dx, which I can say as per the question, I can replace this with what? N. And you can see from here that 0 to a fx, 0 to a f2a minus x dx can be replaced with n. So we can say that our answer should be m plus n. There is an option that is B, no, D is the correct option in this case. In the next MCQ, we are given secant square sine inverse x over under root 1 minus x squared dx is equal to, is what we have to find out. So clearly we are going to consider sine inverse, like the substitution is what I'm talking about. I'm going to take sine inverse x as t. So sine inverse differentiation is what? 1 over under root 1 minus x square, right? Dx is equal to dt. Now check if I write this as what? Integration secant square. I can replace sine inverse x as what? With t, and this thing that is 1 over under root 1 minus x squared dx can be written as dt. So this is going to be secant square x dt. And for secant square, the integration is what? Tan, right? So it's tan t plus c. Later we can replace t with sine inverse x plus c. Yes, so we can see that we have an option, that is B is the correct option in this case. Now in this question, we have to evaluate integration 1 minus x square under root x. So what we'll do here is to multiply this. That means opening this bracket, we can see that 1 multiplied by this results to give you what? This will give you under root x, which I can write x raised to the power half minus, on multiplying this with this, it should give you what? X raised to the power 3 by 2, right? 1 this is x and this is x raised to the power half, right? So its multiplication will give you x raised to the power 3 by 2 dx. We have this as I is equal to. Now we can apply integration directly over here. So it's going to be x raised to the power 3 by 2, and that divided by 3 by 2. So it's same as multiplying with 2 by 3. And this is going to be x raised to the power 3 by 2 plus 1, that is 5 over 2 multiplied by 2 by 5 plus c. So we'll say this is the answer for this case. Then the next question, we are given that e raised to the power integration e raised to the power x tan x plus 1 plus secant x dx is equal to e raised to the power x fx plus c. Then we have to write fx satisfying this relation. So what we will do here, keeping e raised to the power x outside, we will be multiplying this. This way what we are going to get, let's say if I write, this is I is equal to, we don't need to place an I is equal to, as you can see there is already an equal to sign over here. So we can straight away solve this. This is e raised to the power x outside only. Inside, as I said, I'm multiplying secant with tan. So this is secant x dot tan x, and 1 multiplied by secant x is secant x dx, and must write down the RHS over here, e raised to the power x fx plus c. Now here we are going to apply this relation, that is what we know from this, that is integration e raised to the power x fx plus f dash x dx can be written as e raised to the power x fx plus c. So this is what we are going to do in this case. Now for that, I'm going to consider secant x as fx. So let's say if I take fx as secant x, then f dash x is what? Differentiation of secant x is secant x dot tan x. So therefore, this is going to be f dash x. So using this property, we can write our LHS will become what? Its integration will be e raised to the power x fx, right? And what is fx here? Fx is secant x. And on the RHS, it is e raised to the power, okay, we missed plus c. Okay, on the RHS, we have e raised to the power x fx plus c. So clearly c and c get cancelled. And later cancelling this also, we can say now the fx is what? Fx is secant x. So we'll say we have to find out fx, and we got this as secant x. Next question here is to find the integration dx over 5 minus 8x minus x squared. So from here, you can clearly see that we have to do completing the square first. So let's say if I begin with completing the square, I can write this as I. The first thing that I'll do is to take minus common over here. As I can see, the square term is negative. So rearranging them, this is x squared positive 8x, as I've taken minus common, minus 5 dx. Now continuing with this is integration 1 over. Now I'll do completing the square over here. So this is a square plus 2 times a is clearly x, and b what I should write so as to obtain 8x has to be 4 plus b square and minus 5 copied. Since we added 4 square, then I have to subtract 4 square dx. This is I is equal to integration 1 over. Let's check for this part. This I have to keep right outside. This is how much? Negative 21 outside, but then there is a minus over here, so it will come as positive 21, and minus this on this part, right? On completing the square, I can write this as x plus 2 whole square dx. Later what I can do is to write 21 as under root 21 whole square, right? This is what we will do here. And after that, we are going to apply this direct property over here, the fact that integration a square minus x square is equal to 1 over 2a log x plus a over x, a minus x, a plus x. Sorry. So I can write this as I is equal to, this integration is going to be at 1 over 2 times a, and 2 times a is what? 21, under root 21 in fact, right? So and then log mod, this is a plus x, a clearly is 21 under root, plus x, x is x plus 4, that whole divided by under root 21, minus of this is minus x minus 4, it will be plus c. So we'll say that this is our final answer. The next, you can see that I have taken two questions, and you can figure out that we have in these two questions, we have the same numerator, and this is also same over here. What's difference here is this. This is 2 minus cos square x, and this is 1 plus sine square x. In fact, if I write cos square x in terms of sine square x, we are going to get this only. So the two questions will be same in fact, except for the one step of simplification. So if I write this as I is equal to 2 cos x, that whole divided by 1 minus sine x. And this is, as I said, I'm going to write cos square x as 1 minus sine square. So it's 1 minus minus plus, that is sine square x. So you can figure out this is 2 minus 1 is what? 1. 2 minus 1 is 1. So therefore, this is what we got the right. So you can see, as I said, that both questions are same over here. So now we can do integration, and for that we'll be using substitution. So I'll be taking sine x as t. Sine x differentiation is positive cos x. cos x dx is equal to dt. So now our question is going to be transformed over here. So I can simply erase one of them and place this over here. And since we have done this part, we can straight away write from here only. So this is I is equal to integration. This is 2. 2 should be outside, right? Yeah, 2 should be outside. And this will be dt. And this is 1 minus t multiplied by 1 plus t square. Yeah, dt I've already did it. I should write dt over here, right? This one. Next, we know that we are going to apply the partial fraction in this case. So if I do so, the partial fraction I'm going to do on the right hand side. So this is 2 over 1 minus t into 1 plus t square, right? Should be written as what? A over 1 minus t plus, this is quadratic, right? So bt plus c over 1 plus t square. Now simplifying this, this is going to be a times 1 plus t square plus this is bt times bt plus c times 1 minus t. Now placing t as what? T as 1, right? If I take t is equal to 1, what I'm going to get this as, this will vanish to become 0. This is 2a, right? Yeah, 2 times a. This is going to vanish as it is, this will result to give you 0. So this is coming as 2a. So therefore we got a as what? A as 1. So from here we got a as 1. So I can write over here and erase this part, right? We got a is equal to 1. Next we have to get the value of others. So I'm going to place t is equal to 0. Placing t is equal to 0, this is going to be a, and this will become 0. So it's a c times 1, so which is c only. Placing a as 1 over here, we get c as what? 1. So let me erase this. We got c as 1. Now to get a b, I'm going to place t as minus 1. So placing t as minus 1, this is 2 minus 1 square is what? That is 2a, and plus minus, that is minus b plus c into, this is going to give you 2. So now this is 2 on this side. This is 2a minus b, placing c as 1, right? So it's going to be minus 2b plus 2. This get cancelled, and placing a as 2. So we can say this is 1 minus 2b. So that means b is equal to, right? What I did, this is 2 get cancelled, 2a, right? And a is 1. I did something wrong over here. So from here we can see that it is 2b is equal to 2 times a, and a is 1, right? So therefore b is also coming as 1. So from here we got b as what? 1. So in fact, a, b, and c, all of them is equal to 1. So now we are going to substitute this. So after substitutions, what we are going to get here as I is equal to, this is a times, which is a is 1, right? A times 1 minus t dt plus bx, right? So this is t over 1 plus t square. I'm writing from here, right? Plus integration c, which is 1 here, 1 over 1 plus t square. Well, dt should be here also. This is what? Log. This should be, yeah, that's log mod 1 minus t. And here we are going to multiply half, sorry, 2 and half over here. So taking this as t, this is I mean, say taking this as z, this is 2z, right? So we can do it directly, log mod 1 plus t square. And this is what, tan inverse t, right? So this is tan inverse t plus c. Next is to do substitutions. The substitution, that is what we took, ts sin x. So if I apply this, this is I is equal to log mod 1 minus sin x plus this is half times log mod 1 plus x square. Okay, I think we made a mistake here, that when we applied, took this as t, by chain rule there will be minus also. Okay, next is this is half log 1 plus replacing t with sine, so it's going to be sine square x plus this is tan inverse sine x, right? This is tan inverse sine x plus c. So this will be the end result of this question. The next question is to find the value of integration 0 to 1 over e raised to the power x plus e. Now this is an MCQ, so therefore we will write I is equal to, what I'm going to do here is to multiply divide by e raised to the power x, the numerator. So if I divide it, right, so it's going to be what, this is dx only, this is e raised to the power x multiplied and dividing this by e raised to the power x, what we are going to get here as 1, right? And this will become e over e raised to the power x. Now next we are going to take this as t. So we'll put this as t. So that is 1 plus e over e raised to the power x. If I take it as t, let me simplify this. I can write this as e dot e raised to the power minus x as t only. Now on differentiation, this is 0 and this is, from here by chain rule we are going to get minus. So minus e dot e raised to the power minus x dx is equal to dt, which I can write like this also, dx, right, is equal to dt. Well, this should come here. Now I can see that we need one, we have e raised to the power x over here, so I'm going to multiply and divide. I'm going to multiply by, let's say I multiplied and I'm going to divide it by, not e raised to the power x, sorry, by e raised, simply by e. So I'm going to multiply here by minus e and divided by e. This way we can find out. Now I'm not going to change the limit over here, right? This is because this is an MCQ. So we may simply find the, without placing the limit, we'll find the value. Now its integration will be what? Log mod this, right? That is 1 plus e over e raised to the power x. And now next is to place the limit. So I'll place the limit over here. So this is I is equal to minus 1 over e. If I keep it outside, this is log. I'm going to place the upper limit, placing x as 1 over here. This will give you what? 1, right? E raised to the power, e raised to the power. So this is 1 and this is 1. That is log 2. This is log 2 minus, I'll keep it outside as this is independent of x. Next, I'm going to place the lower limit. E raised to the power 0 is what? 1. So finally we'll get minus log mod 1 plus e. Now when I check the option, we don't have anything as a minus, right? So I'll keep this minus inside. So on inserting this minus, so this will become positive. So let me write down this first. This is log, positive log 1 plus e, and this will become negative minus log 2. So here we can apply the property of log a minus b, which is log a over b. So this is log 1 plus e over 2. Yeah, we have, yeah, this is what the A option is correct in this 1 over e log 1 plus e over 2. Now, in this question of assertion and reason based question, many of you get confused. That's why I've taken these two properties together in order to show you the justification. Well, the first assertion, it says that we have this thing, right? Integration 0 to 2 pi sine cube x dx is equal to 0. And we assume this reason to be just because an odd function. That's not true. Odd functions is an even function is applicable when we have integration. The limit is in the form of minus a to a and not when we have 0 to a. Here we have 0 to 2 pi. If it is equal to 0, like if you prove that the assertion is correct, right? But look into the reason over here. Reason says that this is an odd function. Well, this is true. Sine cube x is an odd function, but we are getting this as 0 not because of this, not because of this property, right? Because of this property. So let's first figure out what is whether assertion is true or not. So I'm going to take fx as what? This is sine cube x. Then if I apply this, right, I'm going to apply f2a minus x. So that is 2a is 2a is pi here minus x. This is going to be sine cube 2 pi minus x. So this is landing on fourth quadrant, right? Fourth quadrant sign is negative, so it's sine 2 pi minus x is minus sine cube x. And therefore we can say which is minus of fx. So you can see that here f of 2a minus x is minus fx, so it should be 0. So we can say yes. Assertion is correct over here. Well, reason is also correct, as I said that sine cube x is an odd function. But this is not the correct explanation. Here we got 0 by applying this property and not by the odd or even. So it's a correct answer will be what? Assertion is true. Reason is also true, but it's not the correct explanation. B should be the correct option. The next question here is to evaluate 0 to pi integrals x sine x over 1 plus cos square x dx. Now, the first thing that we should think about is to get rid of this x, and then only we can find its integration. And for that, we are going to use this fact that 0 to a fx dx is same as 0 to a integrals fa minus x. So what I'll do here, I'll consider this to be say I only and mark this as equation 1. And by applying the property that is 0 to a is pi over here, x can be written as this is pi minus x, right? By using this property. And similarly, sine x will turn as sine pi minus x. Below we have 1 plus cos square x will be written as pi minus x dx. Now we'll simplify here. This is 0 to pi, keeping this pi minus x sine 180 minus theta is what? Sine theta, second quadrant, right? So it's going to be sine x. And this is 1 plus, although this is coming as negative, but there is a square over here. So we'll be writing 1 plus positive. Well, pi minus x. Cos pi minus x is minus cos x, but we have a square over here. That's why I'm writing cos square x. This is equation 2. Next, I'm going to add these two equations. So that is 2i 0 to pi. You can see we have the same denominator. So this is 1 plus cos square x. And look into this part. If you add this with this, right? So you can see that by taking sine x common, x and minus x will get cancelled, right? So I can write directly as pi times sine x. That's what we will get by adding 1 and 2. Now here onwards, we are going to do integration by substitution. So if I use this space, I'm going to take, let me eliminate what is not now needed. So I'm going to put cos x as t. So cos x differentiation is what? Minus sine x dx. is equal to dt. So I can keep this pi outside, that's better. I'm writing this pi outside, and I'll place a minus sign over here, and this is minus pi. Now, so this is 2 times I to I is equal to minus pi integration. Well, limit we should change later. I can write this as 1 plus t square, and this is 1 over dt, right? This is going to be this into dx will make it dt. Now we have to change the limit over here. So for changing the limit, what you can see, I'll use this space. For changing the limit when x is equal to what? X is equal to, say, lower limit as 0. So cos 0 is what? Cos 0 is 1. And when x is equal to what? Pi. So cos pi is what? Minus 1, right? That's minus 1. So next what we are going to do is to change the limit. Well, we have changed it. So I can write minus 1 and 1. This is minus pi. Now this is 1 plus t square, right? Is what? Tan inverse? Yeah, it should be tan inverse. So I can write this as tan inverse t. So this is minus tan inverse t. And the limit over here is minus 1. Okay, we need to think a bit. We did a mistake over here. When x is 0, t is 1, right? So you can see that. I need to write it again. When x is equal to 0, the lower limit was 0. So this is 1 and this is minus 1. So we need to take minus common, right? And to write them in order where this will become minus 1 and this will become 1 over 1 plus t square, unnecessary step. So this is 2i is equal to pi. This is tan inverse t. And the limit is minus 1 to 1. Now this is 2i is equal to, this is pi. Placing the upper limit first, tan inverse 1 is what? Pi by 2. Oh, sorry, pi by 4. So there's a minus and another minus pi by 4. Okay, one more step. This is 2i is equal to pi. This is 2 pi by 4, which is pi by 2. So now if I transpose 2 as well, I get I as pi square by 4. So yeah, after evaluating, we'll get I is equal to pi square by 4. The next question is to evaluate this integration e raised to the power 2x minus e raised to the power 2x over same thing in the denominator with a plus sign in between. So this can be done by substitution. We are going to take this as t. So if I put e raised to the power 2x plus e raised to the power minus 2x as t, so this will, its differentiation is what? 2 times e raised to the power 2x and minus 2 times e raised to the power minus 2x dx should give you dt. If I take 2 common, so this is e raised to the power 2x minus e raised to the power minus 2x dx is equal to dt. So what we'll do here is simply to multiply a 2 over here. I should do in the next step. So I can write this as, after dividing by 2 and multiplying by 2, this is e raised to the power 2x minus e raised to the power minus 2x dx, and below it is e raised to the power 2x plus e raised to the power minus 2x. Now by substitution, what we get? We'll get half. This is integration 1 over t dt. That's easy. So this is half log mod t plus c. One more step, we'll be placing the value of, we'll be resubstituting here, replacing t with this. We are going to get what? This is log e raised to the power 2x plus e raised to the power minus 2x plus c. That should be our answer. Now for this question, we are going to take root x as t, right? So this is putting root x as what t is differentiation. This is what I'll replace with t. This differentiation is 1 over 2 root x. Dx is equal to dt. So if I rewrite the question over here by multiplying with 2 and dividing. So first I'm multiplying and dividing by 2 multiplied by cos root x dx. So by substitution, 2 is outside. This will become what? Cos t, and this will be replaced with dt. So I is equal to, so what's the integration of cos? Cos is sine, right? Positive sign. So this is sine t plus c. Further, we can write this as 2 sine, replacing t with what? Under root x plus c. Yes. So this will be the final answer after evaluating this.